Blue skies whisper secrets of endless possibilities. Hi everyone. In this video we'll go through a topic related to permutations and combinations. We will go through principle of counting.
Now, what is permutation? Permutation is nothing but arrangement of objects or things or numbers or of alphabets or people. Now, for example, say you have a PIN number or a lock, say a mobile lock or a mobile PIN number, right? And say the PIN number is 6723. Just an example. This is in a particular sequence. So you have first digit as 6, second digit as 7, third digit as 2, and fourth digit as 3. Now, if I change the sequence, I'll make it like this 6327. Will the lock work? If I try to unlock the mobile with this particular pin, will it work? It will not work. The sequence of the numbers is very important. So, like this, you could have multiple arrangements, right? One is 6327, then you could have 2367, or you could have 7362, right? There are multiple ways of arranging these numbers. So, these arrangements are called as permutations. Now, similarly, say you have digits 1, 2, 3, 4, 5. Digits 1, 2, 3, 4, 5. 5 digits are there, and you want to form 2-digit number, right? 2-digit number. For example, now how many 2-digit numbers you can form with these digits, with these 5 digits? So you can have 1, 2, 1, 3, 1, 4, 1, 5. You could also have 1, 1, right? Then you could have, now I'll take number 2, right? 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. Then I'll take number 3, 3, 1, 3, 2, 3, 3, 3, 4, 3, 5. Then I'll take number 4, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5. 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. So like this, I have formed 2-digit numbers with these 5 digits. So how many are there here? Here you have 5 numbers, 5 numbers, 5, 5, and 5. So you have totally, if you add all this, you have 25 numbers. 25 numbers can be formed using these 5 digits. Using these 5 digits, 25 2-digit numbers, right? Similarly, you can form 3-digit numbers also, right? You can form 3-digit numbers like 112, 113, 114. So you have multiple such combination. Now, the easier way to do this, see, you cannot write all these arrangements like this. So if you have bigger numbers, say you want to form 4-digit numbers, 10-digit numbers, right, out of 100 digits or whatever, right? Then it's going to be very tedious, very lengthy, right? So the easier way to do this is, say you have 2 digits, right? You form 2 digits. Say you have 2 boxes here. This is the first digit. This is the second digit, right? Now here, say how many ways can I form the first digit? I have 5 digits, 1, 2, 3, 4, and 5. I can use any of these digits in the first digit, right? So like this, I've used 1, 2, 1, 2, 3, 4, 5. So the first digit can have 5 numbers. So I can use any of these 5 numbers. So I will write 5 here, right? Now, what about the second digit? Second digit also I can use 5 numbers, right? Like this, 1, 2, 3, 4, 5. Here again, 1, 2, 3, 4, 5. Second digit, right? Second digit also I can use 5 numbers. So 5. So now what I will do? I will multiply. 5 into 5 is 25. See here, we got the same answer. Here we wrote down all the numbers and got the total number of arrangements that can be made with these 5 digits. Here, this is a simpler way, right? You call this as the event. So you can call this as putting first digit is an event. Putting second digit is another event. You just call it as another event. So you have two events, right? And number of ways, number of ways, number of ways you can put this first digit is 5 ways, right? Five numbers. So you have 5 ways. And similarly, second digit, you have 5 ways, right? So now what I'll do, I'll find the number of ways in which the first event is occurred and the number of ways in which the second event can occur, and then I multiply. Suppose, say this is m ways, I'll generalize it, and this is n ways. I can put the first digit in m ways. Say for example, I can put the first digit in m ways and I can put the second digit in n ways. Then what is the total number of ways or total number of occurrences or total number of arrangements? So you can say anything. Total number of arrangements or ways or occurrences or outcomes, right? Anything, right? Total number would be m into n. M into n. This is nothing but multiplication principle of counting. That is, first event, say it will take m different ways, and second event will take n different ways. Then the total number of ways or occurrences of the event is m into n. So this is multiplication principle of counting. So basically, you can actually write all the combinations or write all the arrangements, but by using multiplication principle of counting, you can easily do it without writing every arrangement. So like this, 5 into 5, m into n. Now, one thing you notice here, we have repeated digits also. So if you look at these numbers, 1, 1, it's repeated. 1 and 1 is repeated. That is, first digit and second digit are repeated. Here 2 and 2. Here 3 and 3. 4 and 4. 5 and 4. Now all these are repeated digits. This is what we call as repetition. Numbers are repeated, digits are repeated, right? Now you could get a question as to, when you are forming the arrangements, do you want repetition or not? If you want repetition, then it is 5 into 5, correct? Now say I don't want repetition, right? Now say I don't want repetition. So what will happen? I'll cancel these arrangements. I don't want these repeated numbers. So it will be, how many combinations? 1, 2, 3, 4. 4, 4, 4, 4, 4. You are removing all repeated numbers. So it will be 4 plus 4 plus 4 plus 4, which is 20. The answer is 20 if repetition should not be allowed. Now, we can use this multiplication principle of counting and get this answer. How? So I need to form two digits. So let me put two boxes here, right? Two digits, right? This is the first digit. This is the second digit. Now, how many numbers do I have? I have 1, 2, 3, 4 and 5. So I have 5. So now in the first digit, I can select any of the 5 digits. So 5 digits are available. So 5. There are 5 ways or 5 numbers, 5 digits. Right? I can put 1 or 2 or 3 or 4 or 5 as a first digit. So 5 ways. Now, what should be my second digit? Second digit, see, this is the number of digits, 5 digits. Okay. So similarly, if I have to get the second digit, how many ways are there? Now, I have assumed that I have chosen one digit already. Say I have chosen 1, for example. Say I have chosen 1. I have chosen 1. Right? 1 is my first digit. Then how many digits are left? I'll have 2, 3, 4 and 5. Because 1 I have already chosen. And I don't want repetition. No repetition. No repetition. So I can't have the same digit. I can't have the same digit in the second digit also. It should be different. It can be either 2, 3, 4 or 5. Right? It can be either 2, 3, 4 or 5. So how many occurrences? How many occurrences, or how many ways, or how many numbers? In this example, it is numbers. How many numbers are there? 4 numbers, right? So I can have 4 numbers, right? It can be either 2, 3, 4 or 5. And here I have 5 numbers, right? First digit can have 5 numbers. 1, 2, 3, 4, 5. I can have 5 numbers. Here I can have only 4 numbers. Because one digit you have already chosen. So remaining digits is 4, right? Let me repeat it. Here, how many ways to choose first digit? You have 5 ways, right? You have 5 ways. And here, to choose a second digit, how many ways? One digit I have chosen, right? Just for example, I said 1. One digit I have chosen. What is the remaining digits? What is the remaining digits? 4. 4 ways, right? Now I'll multiply. Now I'll put the multiplication principle of counting. Multiply. 5 into 4. It's 20 ways, right? Here also we got 20 ways. By writing down each arrangement, we got 20 ways. Now this is an easy way by using multiplication. By using multiplication principle, I can directly get the total number of ways, which is 20 here. So now we understand the difference between repetition allowed and repetition not allowed. No repetition. This is the difference. Now let's take another example. So given 4 flags of different colors, so there are 4 flags of different colors, right? Say for example, I've taken yellow, orange, red and green. How many different signals can be generated? How many different signals can be generated if a signal requires 2 flags, one below the other, right? You need to form a signal and it needs to have 2 flags, right? Basically 2 colors. Now I have 4 combinations, 4 flags. Using these 4 flags, I have to form a signal which contains 2 flags. Now this is a signal. It contains 2 flags. With these 4 flags, we'll try to find signal with 2 flags. We'll write down all the arrangements, right? We could have yellow. Let's call this yellow, orange, red, green. Yellow with orange. Then I can have yellow with red. I can have yellow with green, right? I can have then yellow with orange, yellow with red and yellow with green, like this, right? Yellow with orange, yellow with red and yellow with green. So like this, I can have yellow with orange, yellow with red, yellow with green. So there are 3 signals here, 3 ways, three ways of forming signals. Now I'll go with second combination, right? I can take orange also now. Now I'll take orange with yellow, orange with red and orange with green. Orange with yellow, orange with red, orange with green. So like this. Now this is the second combination. I have orange with yellow, orange with red, orange with green. Now we've done with orange. Let's take with red. Let's have the first signal as red, right? So red, I can have red with yellow, red with orange, red with green. So red with yellow, red with orange and red with green. So red with yellow, red with orange and red with green. Again I have 3 here, 3 combinations. Now we'll similarly do with green, right? So green with yellow, green with orange, green with red. So I have green with yellow, green with orange and green with red. So again I have 3. Now what is the total number of signals that can be formed? Now total number of signals that can be formed using 4 different flags. We have 4 different flags. It is 3 add this 3 plus 3 plus 3 plus 3, which is 12, right? Now I'll use multiplication principle. So simple. So I need two flags, right? This is a signal. I need two flags. I need to first get the first flag, then second flag, right? So this is one event. Event of forming the first flag is one event. Event of forming the second flag is another event. Two events. Now, how many ways? How many flags are there? I have four flags. Four flags. So I can choose any of the four. So four ways. Four ways. Now, in the second flag, say I've chosen one flag already. So I'm left with three flags. What are the remaining flags? One flag is chosen. One flag is chosen, right? How many flags are left? Three flags. So 4 into 3. 4 into 3 is 12, right? We got the same answer. So this is what is called as principle of counting. So remember one thing, here also repetition is not allowed. If you look at this, there is no repetition. Why no repetition? I need to form a signal of different colors. The colors for both the flags should be different. I cannot use the same color, right? In a signal, I cannot have this also red and this also red. I cannot have the signal with two red flags. So therefore, it is no repetition, right? Therefore, we have not repeated any combination. We have not taken yellow, yellow, orange, orange, red, red, green, green. We have not taken. Had we taken, we would increase the number of combinations, right? Now, in this case, there is no repetition. So, assume that they told repetition is allowed. Assume they told repetition is allowed. The answer will change. If repetition is allowed, what will happen? I have two flags here, right? First flag, four ways. Second flag also four ways only. Because repetition is allowed. First flag I have yellow, orange, red, green. Second flag also I can choose yellow, orange, red, green. So 4 into 4 will be 16 ways, right? If repetition is allowed. Here also, since repetition allowed, I'll have another combination. Yellow and yellow. I'll have yellow, yellow. Here I'll have orange, orange. Here I'll have red and red. Here I'll have green and green. So 4 combinations will increase. So we got 12. Another 4 will get added and it will get 16 ways. And using multiplication principle also we'll get 16 ways. Now let's look at another example. Find the number of different signals that can be generated by arranging at least 2 flags in order, one below the other on a vertical staff if 5 different flags are given. 5 different flags are given. Vertical staff is nothing but vertical pole, right? Vertical staff is nothing but vertical pole. Now on this vertical pole, I need to have 2 flags, one below the other, right? 2 flags, one below the other. And I have been given 5 different flags. Similar to the other problem, only difference is here, I have 5 different flags. Here we had 4. Here we had 4. In this example, I have 5 flags and you should have at least 2 flags. At least 2. Right? It's not only 2, at least 2. At least 2 means what? At least 2 means I could have 2, 3, 4 and 5. I could have 2 flags, 3 flags, 4 flags and 5 flags. So you could have 2 flags or 3 flags or 4 flags or 5 flags. Right? Now, how do I find the combination? So, here I'll have to take first combination, say 2 flags. Let's go step by step. First we'll find number of ways or number of occurrences with 2 flags. Now with 2 flags, I have a vertical staff. I need to form 2 flags and I have 5 flags. Right? So simple. We'll use multiplication principle of counting. 5 flags. So the first flag I'll get 5 ways. Second flag, one flag I've already chosen. The second flag should be of different color. So how many colors are left or how many flags are left? 4 flags. 4 ways. So I'll multiply. So 5 into 4. 20 ways. Now I'll do the same thing with 3 flags. Right? Now I need to form a vertical staff with 3 flags like this. Now, how many ways for the first flag? 5 ways. Second flag, 1 is chosen, right? 1 is chosen here, so I'll be left with 4. For third flag, 2 are chosen now. This one and this one is chosen. 2 flags are chosen. How many is left? I have 3 left, right? Out of 5 flags, 2 are chosen, right? So I'll be left with 3 flags now. So 3 ways. Now I'll multiply. So 5 into 4 into 3. So this is nothing but 60. So 3 flags is 60 ways. Now I'll do the same thing with 4 flags. Right? I have a vertical staff. I need 4 flags here. So total flags, available flags is 5. First flag, I have 5 ways. Second flag, 4 ways. Third flag, 3 ways. Fourth flag, 2 ways. Because here you have chosen. 1 is chosen. 2 are chosen now. Here 3 are chosen. So you are left with 2 flags now, finally. You keep reducing 1 flag at a time here. So now you multiply 5 into 4 into 3 into 2, which is 120 ways. Now I'll take 5 flags, right? I can have 5 flags now in the vertical stuff. 2, 3, 4, 5. Right? Now here again, first flag I have 5 flags available. Second one, I have chosen 1, so I have only 4. Third one, I have already chosen 2, so I have 3 left. Then for the fourth one, 3 are chosen. Out of 5, 3 are chosen, so I am left with 2. Last one, 4 are chosen. Out of 5, 4 are chosen, so I am left with 1. So I'll have to multiply 5 into 4 into 3 into 2 into 1, which is nothing but 120. Now, total ways now. Total ways is, I have to add up all this. This one, with this one, with this one, and with this one. So, I have to add up 20 ways plus 60, 20 plus 60. Here I have 120 plus 120. So, it's total 320 ways. So 320 ways is the answer. So basically, since there is at least here, you could have at least 2 flags, which means you could have 2 flags, 3 flags, 4 flags, 5 flags. So if I find combinations for each of these, 2 flags, 3 flags, 4 flags, 5 flags, and then add everything, I'll get 320 ways as the answer. Now let's take another example. Find number of 4-letter words that can be formed out of letters of the word rose, where repetition is allowed. So, they've given 4 letters, ROSC, right? And you have to find different combinations of words, right? You have to form different words using these letters ROSC. How many words can you form using these letters ROSC? Now, so basically, say we'll draw 4 boxes here, because you need to form a 4-letter word, right? 4-letter word. Now, if you use the tedious method, right, lengthy method, you'll have ROSC, then you can have ORSC, then you can have SORE, then you can have SOER. So you can go on like this. It's lengthy. You can keep on going and you'll get final number, right? But we will use multiplication principle. We'll use multiplication principle of counting. Now how do we do that? So first we'll start with first letter, right? Now remember here repetition is allowed. So you can use the same letter again and again. So first letter, how many ways? There are 4 letters, right? R, O, S, C. So 4 ways. Now second letter, repetition is allowed. So again I can use the same 4 letters. Third letter, repetition is allowed. So same 4 letters. Fourth letter, again, any of these 4 letters. So 4 ways, right? So now I'll multiply like this. So it'll be 4 into 4 into 4 into 4, which is 256 words, right? I can actually form 256 words using these 4 letters with repetition. Now, if I modify the example and say repetition is not allowed, now if I say no repetition, right? How many words can I form? Number of words using ROSC without repetition. So let me put a 4-letter word here, 4 boxes again. So what I'll do, so here I have 4 letters. First box, 4 letters, right? ROSC. So 4 ways. Second box, I have chosen 1 year. What is the remaining letters? 3. Now third box, I've chosen 2 year. 2 letters I've chosen. I'm left with 2 letters. So 2. Now fourth box, 3 letters are chosen, right? 3 letters are chosen. How many letters are left? 1. So 1. So basically now I'll multiply 4 into 3 into 2 into 1. So this is going to be 24 ways. So if there is no repetition, it's 24. If there is repetition, it is 256 words. 24 ways or 24 words. I can form 24 words using these letters ROSE without repetition. Now let's look at few more examples. How many 3-digit numbers can be formed from the digits 1, 2, 3, 4 and 5, assuming that repetition of digits is allowed and repetition of digits is not allowed? Okay. So we need to form 3-digit numbers. So let's put 3 boxes, 3-digit numbers. How many digits do we have? 5 digits, right? So now, so first digit, you have 5 ways. Second digit, repetition of digits is allowed. So you can repeat. That means again you have 5 here. Third also you'll have 5, right? Because repetition is allowed. Then I multiply. Multiplication principle of counting. I multiply. So I'll get 125 ways, or I'll get 125 numbers, right? So 125 ways. Now in this case, repetition of digits is not allowed. Second case, not allowed. So first digit, I have 5. I have chosen 1. So I am left with 4. Here I have chosen 2. So I am left with 3. I have 5 digits. I have chosen 2. 5 minus 2, 3. I am left with 3 possibilities. So it will be 5 into 4 into 3, which is 60 ways. So this is the answer. Now we'll take the second example. How many 3-digit even numbers? So notice this, even numbers that can be formed from the digits 1, 2, 3, 4, 5, 6. If the digits can be repeated. It can be repeated. Even numbers. So when you have some conditions like this, even number. What is an even number? Any number that ends with 2, 4, 6, 8 and 0. Right? If the last digit has 24680, then it is called as an even number. For example, 20, 22, right? Or 72, 76. The last digit should be even number if the entire number should be even, right? Or 92, 98, 94. The last digit should be even number to make the entire number as even. So let's focus on the last digit. So last digit, you have 2, 4 and 6, right? In this entire list of digits, 2, 4 and 6 can be placed here. It can be 2 or 4 or 6. 2 or 4 or 6. How many ways? 3 ways. 3 ways. Now, I have chosen one digit here, right? So, for the second digit, or let's start with first digit. For the first digit, how many digits I have? 3, 6 digits, right? Though I have chosen one here, I have still all 6 digits because repetition is allowed. And second also I'll have 6. But for the third I'll not have 6 because it has to be even number. Since it is even number, I can only have either 2 or 4 or 6. So it's only 3 ways. So 6, 6, 3. So multiply 6 into 6 into 3. This is the answer. So it is 108 ways. Let's look at another example. How many 4-letter code can be formed using first 10 letters of the English alphabet if no letter can be repeated? 4-letter code, right? So there has to be a code with 4 letter, right? We'll put 4 boxes. And using 10 letters of the English alphabet. 10 letters. See, it doesn't matter which are the letters. 10 letters and you need to form 4-letter code. Right? First letter, second, third, fourth. Now, simple. No letter should be repeated. Right? So, no letter is repeated. Now, first letter, it could be one out of these 10. So, you have 10 ways, 10 possibilities. It could be A, B, C, D. It could be any of these 10 alphabets. So, 10 ways. And second letter, no repetition. So, if I've chosen one alphabet here, I'll be left with 10 minus 1, which is 9. And third alphabet, I've already chosen 2. So, I'll be left with 10 minus 2, which is 8. And I've chosen 3 now. So, 10 minus 3 is 7. So, 10 into 9 into 8 into 7. So, total codes is equal to 10 into 9 into 8 into 7, which is 50-40 codes. So, we can form 50-40 codes using 10 alphabets with no repetition. Let's look at fourth example. How many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digits appear more than once? So I need to find 5-digit telephone numbers, right? 5 digits. Let's focus 5 digits. So 5 boxes. 5 digits. I need to form 5-digit telephone numbers. And using what digits? 0 to 9. 0 to 9. 0 to 9, how many are there? 10 digits, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 digits are there. Using these 10 digits, I need to form 5-digit telephone numbers. And they've put another condition. The number should start with 67. Every number should start with 67. So basically your first number is 6. First number is 6. Second number is 7. And no digits appear more than once. That means no repetition. No digits appear more than once. So no repetition. So now this is fixed. 6 and 7. 6 and 7 is fixed. So we'll go to third digit. Now you have 10 digits. 6 and 7 is already selected. Right? You cannot have repeated digits. 6 and 7 is already selected. So how many are left? 2 are selected. 10 minus 2, 8. So you're left with 8 digits. So out of 8 digits, you can select the third digit. Now fourth digit. What is fourth digit? 3 are selected now. 6, 7 and this third digit also is chosen. How many is left? 10 minus 3, which is 7. And here 6, right? So 1, 2, 3, 4 digits are chosen. So 10 minus 4 is 6. Now you multiply this. Don't multiply anything here because here it's only one way. Right? Already chosen 6. So 1 digit. 7. 1. Right? Only one way. There's nothing else that you can choose. Only one. Right? 6 here and 7 here. So you have to multiply only this. 8 into 7 into 6. 8 into 7 into 6, which is 336. 336 ways, or I can say 336 telephone numbers. 336 telephone numbers can be formed using digits 0 to 9 and each number starting with 6 and 7. Now let's look at the fifth example. A coin is tossed 3 times and the outcomes are recorded. How many possible outcomes are there?
A coin is tossed 3 times and each time the outcomes are recorded. So every time a coin is tossed, right? What is the possibility? When a coin is tossed, you can either get head or tail, right? You can either get one of these outcomes when a coin is tossed. Now this is tossed 3 times, right? This is tossed 3 times. So what we will do, we'll put 3 boxes. This is first time, this is second time, this is third time, right? So these outcomes are getting recorded. So first time, what are the possibilities? When a coin is tossed, you have 2 possibilities. You can either get head or tail. So 2 possibilities. Second time also when the coin is tossed, you have 2 possibilities. Either it can be head or tail. Third time also, it can be either head or tail, right? So now I'll multiply. So it's going to be 2 into 2 into 2, which is 8 possibilities or 8 outcomes or 8 ways. Now here we have used multiplication principle of counting. So now if we use the tedious method or lengthy method and write down each outcome, we will get, maybe we'll get head first time, then head second time, third time also we'll get head. This is one outcome. Next one is we could get head first time, head second time and tail third time. Again, third combination, we could have head first time, tail second time and head third time, right? Now similarly, we could get head first time and tail second time and third time. Same thing will repeat with tail, right? First time we could get tail and same combinations. We could get H, T, T, H, T and T. So now if you see, there are 8 different possibilities, 8 different outcomes. Same thing we have got using this multiplication principle of counting. So the number of total ways is 8 ways or 8 possibilities or 8 outcomes.
Now let's look at the sixth problem. Given 5 flags of different colors, how many different signals can be generated if each signal requires 2 flags, one below the other? So the signal will have 2 flags, one below the other, and I have 5 flags, right? And I have to use 2 flags to form a signal. So again, so how many ways are there? For the first flag, 5. It should be different colors. That means no repetition. Both the flags should be different, so no repetition. So I have chosen 1. So how many are remaining? 4. So 5 into 4. So total number of different signals is, multiply this 5 into 4, which is 20. So 20 different signals can be formed using 5 flags of different colors. So with this, we've come to the end of this particular topic. If you've liked this video, do press a like and share it. Thank you.